Green,
I think it's green.
green.
No, Aiden said no for green.
And our votes each count for 10.
Oh, yeah.
I'm wearing black.
Much like the other lectures that you've had in the last few days, this one will be short. And the only reason for that is because I'm just reviewing how to mechanically solve systems. This is the method that you should probably get the best at because it's the one that we're going to use mostly when we get to 3x3 systems. And 3x3 systems they're a lot more difficult than 2x2 just because there's a lot more opportunities to have little tiny miscalculations. So anyways, you'll remember this method probably very quickly once we get started on it. But so we learned how to graph. That's where you graph two lines. Hopefully you're not still working on that assignment. If you are, you're pretty much a slowpoke. And then yesterday we got a new assignment on substitution. And I'm sure you're probably still knee deep in that. And then I'm going to add another one on today. So anyways, this one comes at you in 3 levels. So I'm not going to make any weird stuff. I'm not going to make you move stuff around. We're not going to consider the weird ones like no solution and all that stuff. We're just going to mechanically get in and refresh the process. So the first level of elimination, the problems look like this. And I'll see if you remember the process since you've seen it before. Anyone remember? So like if this were Monday or I think Tuesday, maybe whenever we learned it, if it were graphing, we would get y by itself, graph the lines, see where they cross. If it were yesterday, we'd probably take that top y, get it by itself, put it in a box, substitute it in. Today, the other method. Anyone remember? It's we actually don't want them to be exactly the same. Right. So the idea with elimination is that we are going to take one equation and we're going to add it to the other. And what we're hoping for is that when we do that, when we add downwards, one of the variables will auto die. So in a level 1 problem, that is just ready to happen. So like I am committed and ready to go in. So I draw a little line here. And the line just signifies I'm going to do an addition problem. And in math, you can row combine. They're called linear combinations. So if you just go straight down and combine all your like terms. So if you add straight down the x column, those are not our friends. We get 6x. But the y's are our friends because if you add straight down, they cancel. It's because one of them's a plus y and one of them's a minus y. So you don't want your things to be the same. You want them to be one positive, one negative, opposites of each other. And so when the y's cancel out, then we just bring down the equal sign. And then we, of course, don't forget to add 5 and 7, and we get 12. And then what pops out is a little rinky-dinky baby simple equation. Divide both sides by 6, and you now know half of your answer is 2. So just like yesterday, once I know this much, I just write my answer like this, and I just leave half of it blank. So this method is my favorite. Most people usually walk away from Algebra 1, Algebra 2, and just agree this is our most useful method. The trouble with it, the only downside is you don't have that nice convenient box that you had yesterday. You don't have a pretty place to plug the 2 into. So you do have to make a choice and go back and find what you consider to be the most friendly, the user-friendly equation. So in this case, in some problems, we'll have more to choose from, you'll see. But in this one, we just have like the top equation and the bottom. Which one do we like better? Probably the top, just because we're not going to have to deal with that negative on the y. So you could, by the way, use either, and you will get the same answer if you don't mess up, provided that your first answer is correct and you don't make mistakes. If half of us do the top and half of us do the bottom, we're going to get the same number in this y spot. But I'm going to choose to do the top just because it doesn't have that pesky negative in it and take the path of least resistance, So if you put 2 in place of the x, what's 3 times 2? 6. So you get this little simple equation that says 6 plus y equals 5. See, it is kind of like a substitution, right? In that we have to substitute half our answer to find the other half. And then when you solve that, what's y equal? Yeah, 5 minus 6 is -1, and we are done. Okay. Not all problems are quite that quick, but hopefully that reminds you of what the process is. So my next two examples, I'm just going to scaffold them up. I didn't think this lesson needed more than three. But as always, if I go too fast and you want some help when we get to work time, just let me know. We'll do some together. But in the next one, when we scaffold it up just one level, do you guys remember what changes? Maybe if I put the problem up here, then you'll remember what it is that I'm asking you, as far as what is it that changes. What changed? Right. This one is not an auto kill. Like that last one, I sometimes call them fluffer puffers. It's like that last problem was one of the easiest things we've ever done in our lives. Sometimes, though, when you get the problem, you realize that, oh, if I add it together, nothing's going to happen. So do you remember what our solution is? That won't help us. Our goal is to let me say this. See, there are two numbers in the red box and there are two numbers in the green box. And our goal is to make them opposites of each other, right? Negative 8x. Correct. So I look at the red numbers and the green numbers and I ask myself, which ones would be the easiest ones to get to be opposites? And could I turn a 2 and a 7 both into the same number? I could if I turn them both into 14s, but then I have to multiply both equations. So this is a level 2 problem because I don't have to multiply both. I'm not in a position like I will be in the next problem where I have to multiply them both. In this one, if I just take only the top equation and multiply it by 4, what's that going to turn this very first number into? And that's exactly what we want to do, is get it back to look like the one before so that the negative 8x and the plus 8x will cancel. So this is a level 2 just because we don't have to multiply both equations. We can get away with just multiplying one. So what I like to do is take my the distribution. Remember, I only drew one arrow, but don't forget that it multiplies here. Usually if people miss these, it's because they forget that the distribution has to go everywhere. So my new equation on top is what? Mm-hmm. Mm-hmm. 32. Mm-hmm. Right. And then what I like to do is reconstruct the system. And so it takes like 5 seconds. It's nothing worth complaining about. I'm going to take the original bottom equation and just copy it again so that I have a problem that looks like the first one we did together. So, and then I draw my line. The line for me is like my statement of commitment that, okay, I'm ready to do the addition now. And when we add downwards this time, you see that the x's go, right? And how many y's do we get? Negative 1y. And then what's 32 minus 26 or plus negative 26, whatever? Positive 6.
Oh.
It's okay. And then if we divide both sides by negative or negative 1, we figure out that y is negative 6. And we, again, know now half of our answer. So we can construct it like this and say, there's my answer. I just have to go fill in the blanks. So you see now, and I alluded to this when we did the last problem, that we have 3 equations that we could choose from. We can choose like the OG top, the OG bottom, or the new top, right? I wouldn't consider those two on the bottom to be uniquely different because they're the same thing, right? So you have 3 options. I would always say about this that, I wouldn't ever choose an equation that I modified because it's generally going to be bigger numbers. So I feel like this one's probably out of the running. Most of us would probably pick the top just again because of the smaller numbers. Others might pick the bottom because it doesn't have the negatives, to each his own, whatever floats your boat. Like I said, if you don't mess up, it's going to work either way. So I'm going to take the top equation since I'm the guy with the fake pen here. So I'm going to take my negative 6 and I'm going to put it right where that yellow arrow is pointing. Make sure you put it in place of the right variable. What would my top equation say if I substitute? I'm sorry. Perfect. Right. Everyone see the plus 12? I put a negative 6 after a negative 2, became a positive or a plus. And then from here, of course, we subtract 12. And we get 8 minus 12 is -4. Then we divide by -2, and we get x equals 2. And then we complete the puzzle and are done with that one. Still good? Okay. And as I already said, I kind of told you what the deal is. When we get to level 3, we're not gonna, and you'll encounter a lot of problems like this where there's no quick route. Like on that one, our quick route was to spot that -2 and that 8 and say, hey, I can turn you into the guy below you, right? So we're not going to always have that luxury like this one. So the idea here is that there is um, no quick route. I look at the numbers and I say, can I turn a 4 into a 6? The answer is no, not unless you got mad skills with like multiplying by 1.5. And, people just don't do that. So I think to myself, like 4 can't go into 6. So I'm not interested in 4 and 6. And then I say, well, can I turn 4 into 7? And the answer is no. So we're in a position here where, you could divide and try to find workarounds and stuff. But at the end of the day, you almost don't save any time, really. Just change them both. So you just have a choice to make. And sometimes you'll make choices and you'll start to learn like what choices are better than others. Like I'll usually gravitate, if I could see one pair that was already a positive negative, I would probably pick those. But the trouble with these is like if we go in, if Shanessa decides like, hey, I want to kill those X's, they're looking sideways at me. They're both negatives, so we have to change one of the signs. And if Kennedy's like, well, I don't want to kill the X's, I want to kill the Y's. Again, hers are both positive. So no matter how we choose this, we have to mook around with the signs. So there's really no short way. So who do we want to eliminate? Sure, let's do the X's. And what is the smallest number that both 6 and 4 can be turned into? Yeah, 12. Sometimes people say 24 and it'll work. You'll just have a little bit more bigger numbers and more division kind of stuff to do. But at the end of the day, you can use 24, you could use 48, use 96. Anything that they'll both go into is fine. But I like to pick the smallest. Now, the thing about this is you don't want to turn them both into 12s, right? One of them into a negative. So don't mess with both signs or you'll be right back where you started. So what should we multiply the top by? 2 is the first one I heard is 2, and that's fine. But then that means that we're committed on the bottom. What do we have to multiply? -3. So you've got to just pay attention to your signs. And at the end of the day, what you're trying to make sure of is that the numbers are opposites of each other. So you're in full control of that. And then again, I'm just going to rewrite the whole system, turn it into a level 1 and do my thing. So what's my new top equation going to be? Yeah. Perfect. And my new bottom? Perfect. Perfect. Perfect again. You see that the only issue here is there's a lot of opportunities to make mistakes, and we humans tend to do that. So just try to be careful. When we add downwards, the X's will eliminate. And how many Y's? We get 2 of those Y's. Oops, my bad. I forgot to switch tools here. 2Y equals 16. Divide by 2. Y is, and again, like I always do, I'm going to go and construct my final answer, put the 8 in the correct spot. And again, most people, normal people, are not going to choose these for their substitution. Like, why would you? It's weird. So we're going to go back probably to the originals and which one is more attractive. Probably the bottom one. We've got negatives to deal with everywhere. We might as well just pick the one with the smaller numbers. Okay. And I'm going to put that 8 right where that Y is at, because that's what we solved for. So you sure? Okay. All right. What is my new bottom equation going to say when I plug in that 8? Right. And then we do our thing. Subtract 32 from both sides. You get -4x equals -36. Divide, you get x equals 9. Plug that sucker in. Done. I never have actually, I've been doing this a long time and I always say dumb things like, oh, 50 math problems. I don't know how many math problems we just did, but when you really stop and calculate it, sometime you should. We did a dozen-ish, I don't know, maybe more. And every one of those is an opportunity for us to make a mistake. So that's the only real difficulty with this. I don't think the concept of how to do it is hard. It's just that kids all the time say, well, I got a fraction. What did I do wrong? And it's going to be something like right here, someone puts 28. How would they have gotten 28 right there? So I see it all the time because, we just don't show our work anymore. How could someone have gotten a 28 there? Yeah, they just add the 32. They just put this number and this number together like a knucklehead. So you have to monitor yourself and hold yourself accountable for remembering the basics of what we've learned, right? Because that's a lot of chances. There's one, two, three, four, five, six multiplications, one, two, three addition problems, a division problem. I mean, yeah, probably a dozen different little math problems that all have to go right. And then when we get to 3x3 systems, instead of a dozen, it's like 30 or 40 math problems that all have to go right. Oh, you guys switched, you were wearing this hat. Okay. Dope. I'm going to leave the recording alive but paused as always. I'm going to hand out your next assignment and I need you guys working. Well, that'd be great.